It is my absolute pleasure to get to introduce to you Dr. Caleb Shull. Dr. Shull is the Director of Research and Development at the MASH office based in Carlisle, Illinois. Caleb received his Bachelor of Science degree, Master's, and PhD degree from the University of Illinois. I have had the absolute pleasure of knowing Caleb for a long, long time. He's a great thinker. He's visionary, yet at the same time very practical. And I'm excited to hear what he's got to say today about the swine technology adoption conundrum. It's certainly something we talked about a lot in boardrooms at the Carlisle office during my many wonderful years at the MASH office. So let's bring Caleb out here. Let's put him up on the main stage. And Caleb, my friend, the floor is yours.
Thanks, Clayton. Can you hear me all right?
Yeah, your audio sounds very good.
Good deal. Well, thanks for the introduction, and thank you for the invitation to speak. It's been a really good morning and early afternoon. I've enjoyed the presentations and I've learned a lot. A lot of good content's been discussed. I think it's an exciting time to be in the industry. As many people have said, there's technology and data and information is really changing multiple industries, the way that people are using information to learn about customer behaviors, to learn about user patterns, to really redefine business models is happening across the globe. And I think obviously we have desires to see that happen within the swine industry. Brian, I know you said you needed a minute or two to kind of go through why that's not happening as quick in swine production. Certainly, it is a complex situation. I don't know that I'm going to be able to cover adequately in 20 minutes, but I'm going to give it my best shot. Certainly, livestock and animal agriculture is complex. There are examples in dairy and poultry that are ahead of where we're at in the swine industry. I think if you look back at our production systems and barns and the management tools that we're using, they don't look a lot different than they did 5-10 years ago. I hope that's going to be different as we look 5-10 years into the future. But a lot is to be determined. There's the cost of the tools that we're using, tablets, cameras are all becoming more affordable. So it's an exciting time. But I would like to spend some time just talking through my lessons learned. Clayton, you're going to be surprised that I have very little data to share in this presentation, which is against my nature. Obviously, being the director of R&D, I do a lot of controlled work, but I wanted to share at least our learnings that we've had through our experiences with testing multiple technologies and working with a lot of different technology companies, some that have talked today. So I guess we need to start first by asking the question, why is technology needed? I think it's pretty self-explanatory. The benefit and value that data and information can have in shaping what new business models look like into the future. But especially if we look within the swine industry, though, there's clear evidence that we've increased the productivity of our animals. This black line on the chart here is the total pigs born per litter. Clearly, we see a positive trend line with increased pigs born per each sow over time. However, if we were to look at mortality as an example, those trend lines are not positive. If we look at sows, piglets, growing pigs across the board, we have mortality trends that are not headed in the right direction. I think there's multiple reasons for that. Dr. Linares talked about health monitoring. Certainly diseases are more complicated than they were, and management of diseases is more challenging than what it has been in the past. Certainly with the new PRRS strain this year, it's done a lot of damage within the industry. I think our modern pig, though, is different with its productive capacity and needs to be managed differently, which brings me to the last point, the labor issue. I know, Clayton, you mentioned that previously. It is a challenge finding skilled labor that wants to show up to work every day and wants to put the detailed, dedicated work needed to provide adequate care to our animals is a challenge. So I think technology obviously is a tool that we can use to help provide the information to make our team members more efficient at their job and to be able to have, in some cases, manage more pigs more effectively. So I guess to define the conundrum, obviously technology is clearly needed in the swine industry. So why has adoption been so slow, and why do so many technologies not even get to the point we're adopting them? And then why do so many stall out on the left side of this Rogers innovation adoption curve? It's a great question, and I don't know that I have all the answers, and certainly is something that has wrecked or really caused us to think within the MASH office around how do we accelerate innovation, because obviously we want to be on the early end of adopting, but not the bleeding edge of adoption. I think it would be interesting to look and get perspective on where the swine industry is on this bell curve, and does it match this bell curve that Rogers so adequately described. I have questions about whether the volatility in our commodity prices and we've seen massive changes in profit and loss over the last few years. Obviously, that's adds risks. Has that changed the distribution of the innovation adoption curve? Has it made producers more risk averse to taking on new risk, because technology adoption obviously does have some inherent risk associated with it. Is that the case? I don't know, but it is something at least to consider. But again, I don't know that I have all the answers, but I'm happy to try to share my lessons learned, and hopefully it leads to some questions and some good discussion. All right, kind of continuing on the work done by Rogers, I pulled from his summary 5 factors that affect the gradient of innovation adoption. First and foremost is the attribute of the innovation. Obviously, you have to have attributes that are desirable, whether they have an economic return, whether they are attractive to the user. If that's not there, you're going to have a hard time getting innovation adopted. Second is who is involved in the decision making. We often overlook this, but the more people that you get involved in decision making, typically the longer and harder it is to get that adopted. And then who within your organization is making those decisions also influences the speed of adoption. How innovation is communicated to the user is very important. If that user doesn't understand why we're trying to adopt the innovation, if he doesn't or she doesn't understand how to use the technology, then we're going to really struggle with adoption. The culture and social system. Certainly, we see this even within our relatively small geography and footprint that we operate within, that we have different geographical areas that have different cultures, that have different team dynamics. So that needs to be taken into consideration and does affect innovation adoption. But also on the social side, that if we can have networks of producers that talk to each other, and you have people that champion technologies and communicate those success stories to other producers, it certainly increases our rate of adoption. And lastly, the change agents promotion efforts. That is one that typically is done by leadership within an organization, but can be done at all levels. But certainly, the more that you have alignment across an organization, that we are going to innovate and we're going to push a certain technology, the quicker that you'll be able to move. Just kind of put this into buckets, and it's not surprising that only one of those 5 really deals with the what of the technology, and the other 4 deal with the how of the technology. And it just really points out to me that technologies are only as good as the people that are using them perceive them to be. And so it's so important that we understand how people are going to use them, what people's needs are. And if we don't consider that, we're starting from a bad position. So just to kind of hit on those topics a little bit more and discuss some attributes of some successful technologies that we've implemented within the MASH office. And this is a list of 5. There's obviously more than this, but these are just a few that I've found that if you're going to have success at getting the technology implemented, it typically has these characteristics, or at least a few of these characteristics. First is a compelling value proposition. Obviously, we work in a very competitive industry, and if the profit margins are not there, or ROI on a technology is not there, we're probably not going to adopt it. That value proposition includes both the cost and the benefit, and we'll talk more about that in just a little bit. Second is it easy to implement and use? The more complex a technology is to understand, to train, to get implemented, the harder it is going to be to get constant buy-in across the board of that technology. Third is, does it make the job more enjoyable? Technologies are easiest if you have a pull from the production teams. And if you're using the technology to make the job more enjoyable, you're going to have a natural pull. So the more we can take on those characteristics, the better we're going to be as an innovation development team. Fourth is improves animal care. We have, for the most part, really good people in our organization, and I think across our industry, that really want to provide the best animal care. So if we can have technologies that allow our caretakers to achieve that and do better than what we've done in the past, it's going to, again, create that natural pull. Lastly, which is closely tied to the compelling value proposition, is providing predictable outcomes. Obviously, that kind of ties back into the business risk. If the outcome doesn't work, or if we don't get the desired outcome, or the technology doesn't work, that's a big deal for us, and it doesn't take too many times of that happening before the technology gets discarded. And then also we have to understand the implication that if the technology doesn't work, what does that mean? If it's a catastrophic event, certainly that needs to be considered as well, and adds to the business risk. So I just threw a few technology examples that we've successfully implemented within our system, and kind of given them a score across those 5 attributes in terms of how they rank. If we look at antibiotics and vaccines, certainly they check a lot of boxes, and that's probably not a surprise. Those are proven and effective and are reasonably affordable and provide a good animal care, or help us to provide better animal care. So certainly checks a lot of boxes there, and gets those technologies are widely used within the industry. Several nutritional technologies like zinc and phytase as an example, and genetic improvement technologies. I really like those as an example of being able to do innovation in the background. We can implement those, and most people don't know them. And frankly, as the director of R&D, those are attractive because we can get value if they're demonstrated to work in controlled research. We can implement those and get value very quickly, and get fairly repeatable and predictable outcomes. I have post-cervical artificial insemination on the list as well. This is one that has a compelling value proposition, not necessarily because of the value that it creates, but it's very affordable. So it makes it compelling from that standpoint. It's easy to use, allows the caretakers to have an easier breeding process, and then also has resulted in predictable outcomes. So the last one on this list is web-based ventilation controllers. Is a unique example. It's the only one on the list that doesn't, at least in my opinion, provide a compelling value proposition. I don't know that we've fully captured how we're going to earn a return on that investment, but yet we've went ahead and made the decision to put the web-based ventilation controllers in our new buildings, if for no other reason, so that we don't have obsolete equipment in our buildings into the future. So there's a potential lesson learned there, that if you want technologies to get adopted, take away the alternatives. But also there is some attractiveness to those web-based ventilation controllers in terms of what they may enable in the future. They are relatively easy to use and implement. I guess that one probably could be debated, but they've taken those old controllers and put them on screens that are fairly easy to use. And typically they do make the job more enjoyable because they can potentially eliminate trips back to the barn if they can log in and see what's going on in the barn remotely. So just a few examples of successful technologies. Obviously, you see a lot of those boxes checked, and it's not a surprise. as we flip through to maybe some technologies that haven't been as successful within our system, just a few examples here: auto sort, single fixed time AI, microbial technologies, phytogenics, immunocastration. You see less of those boxes checked and more question marks. I think that's not surprising. And as we continue to evaluate new technologies, we need to try, as innovation companies, need to try to check as many of these as possible. And I think the more we can do that, the quicker rate of adoption we'll see. Looking next to some smart technology examples, very similar to the last slide in terms of technologies that have maybe not had as rapid of adoption. We see a lot of check marks, mostly in the compelling value proposition. While most of these technologies, and by the way, we've looked at or are currently looking at technologies in each of these buckets, but most of them don't necessarily have clearly defined value propositions. And those value propositions can be somewhat difficult to measure. We're in the process of trying to understand what measurements we need from a data perspective to better manage our populations. And the more that startup companies or tech companies can work with production systems to help understand that and really start to check some of these boxes rather than leaving them with question marks, the better off we'll be as an industry. Just to go a little bit deeper onto creating a compelling value proposition, I think first and foremost, the swine industry is benchmarked on cost of production for the most part. However, most of these technologies that we've talked about are typically measured on the ability to deliver value. So there's this obvious disconnect that we're measuring performance based on cost, and they're trying to deliver value. So I think we need to keep that in mind as we talk to production companies, or as tech companies work with production companies, that they have to come in with the cost mindset. And cost doesn't only include the capital cost of the technology or the development cost or even the operating cost. It also includes the implementation difficulty, the time that it's going to take people, or distraction that it's going to cause people within the organization to get the technology implemented. So we have to think in terms of the implications of on the cost side to the business. And I love the approach that BJ and others have talked about in terms of incremental improvements and coming in at a low cost. And Scott mentioned the business model, getting that business model right so that you can minimize the cost on the front end, improve these technologies, and try to better understand what value they bring within your system. On the value side, the more that we can put tangible metrics around the value that's created, whether that be mortality improvements, average daily gain improvements, pigs per sow per year improvements, or sort loss in the context of weight prediction, the more that we're going to be successful. Sometimes those are difficult to measure and require multiple barns and multiple geographies to really try to quantify what that tangible metric improvement is. But the more that we can focus on that, the more producers will be comfortable making these investments. The intangible value drivers, enabling future opportunities, is something that is hard to put a measure on, but something that obviously needs to be taken into a consideration. The people impact is hugely important, as we've talked about previously. The more that we can support people retention, provide tools for people to do their job better, the more that we're going to get buy-in from technologies. And then lastly we've talked about it all day, but business transparency, having the ability to learn things that we don't even know today about our business and what drives human behavior, what drives pig behaviors, the more we'll learn. And I think over time, value will build upon itself, and we'll be able to better understand what value these technologies are bringing. We talked about the innovation attributes. Now let's talk a little bit about the how behind these factors that are driving the gradient of innovation adoption. I think I would best describe it as oftentimes there's a gap between people developing the technologies and people using the technologies. And in this case, there's a canyon between the two parties. So I guess the question is, what can we do to bridge that gap, and why does that gap exist in the first place? There's obvious gaps from, whether it be from communication. We have people that are educated in a certain fashion, engineers, data architects, that struggle with communicating directly to producers, but there's opportunities to partner with organizations that allow that communication gap to be filled. There's competency gaps. I mentioned data architects and engineers. We don't necessarily have that skill set, and it's another reason why we should partner with companies that have that skill set, but we don't necessarily always have that competency set that can directly tie into what's needed. And even sometimes infrastructure, IT systems don't necessarily lend themselves to integration in a way. Scott did a really good job around all the backend, describing all the backend systems that can cause problems. That can be a big gap. Testing environment gaps is another area that a technology, a solution, an app may work in an office or a lab setting, but you get it out into a barn in Northwest Iowa or Nebraska or Indiana or Illinois, where there's very little connectivity, or the users aren't technically savvy and don't know how to use technology or problem solve technology. We run into issues. So being able to test the technology solutions in those environments and get that feedback throughout the development phase is extremely important. So just to kind of wrap up here, what's needed to advance smart technology to the next level? I think, in my opinion, it requires a vision and commitment for the future. Scott talked about just making that leap. I think to a certain extent that's true. I think producers also have to demonstrate value along the way. I love the concept of iterative approaches and starting at a low cost proof of concept, and then adding and bolting on technologies from there. Strong relationships are key to bridge that developer user gap. We've had some strong relationships with companies that have been very beneficial both ways, helping them understand the realities of what happens on a farm and understanding the constraints and opportunities on the development side. Field R&D efforts, I think, are a must if we're going to push technology into the industry at a rapid pace. I like to call the living lab approach as needed because the technologies that we're looking at here don't necessarily always lend themselves to a controlled R&D setting. It requires, and in some cases it does, but in some cases it requires multiple barns and getting the technology in people's hands and getting feedback directly. But at the same time, we also have to have a way of measuring success. And in some cases, that takes a lot of barns if we're talking about mortality improvements. Connected systems are a requirement. A lot of talk about this. We have to have connectivity at the site. There's solutions now that weren't available 5-10 years ago, but we'll also have to be able to have systems that talk to each other. The more also that we can bolt on synergistic technologies, the more we can help defend that value proposition. While one technology itself may not be the answer, but if you add a couple of technologies that complement each other, maybe that is the way that we can defend the value. So lastly there, on the technical support, I think that's extremely important because the development doesn't end when you hand the solution off to the producer. The first time that technology doesn't work and there's not someone that can provide a quick solution, they're going to quickly lose confidence in the technology. So I'm excited about the future. We're looking at trying to build that living lab approach and looking at multiple technologies, trying to find what data is going to be most important in terms of unlocking the value that we've talked about. And I'm excited about where the future is headed for a number of reasons. I took the opportunity to go back to my childhood and bring Bugs Bunny back. I did this because to illustrate the point and start the question around, is it the fastest person or fastest company that's going to win, or is it the tortoise there that moves slow and methodically? It's a good question. I don't think it's either personally. I think it's the person that, or the company that and organizations that learn the quickest, not necessarily move the quickest. So with that, I'd like to thank you for the time, and happy to answer any questions.
All right, great job, Caleb. Thank you very much for all that information. You talked about 5 attributes of successful technology implementation, and you kind of showed how you guys had stacked ranks, successful, maybe not quite as successful implementations. When you think about the weighting of those 5 categories, do you have a difference in weighting where you say, you know, some of those factors are more important than the others, or do you look at it pretty equally?
That's a really good question. I think obviously you have to have a value proposition, and that value proposition can come in some of those other attributes, obviously. But if it's not there, then that's first and foremost in my mind. I think the others all complement and add to that value proposition. If the technology has a very compelling value proposition but doesn't have any of the other boxes checked, we still may pursue it because, frankly, we're capitalists and are going to try to pursue every margin opportunity that we can. But the more boxes we can check, the easier it is for us to get comfortable with making investments.
I noticed that one of the attributes you didn't list up there, Caleb, was the ability to validate the value proposition. Is that another one that's kind of an ante to the poker game where you got to be able to do that, or are you comfortable with the theoretical value proposition driving the decision?
No, I think it's you have to measure the success of the technology, and that can come in many different ways, and really depends on what you're trying to improve. If it's a mortality improvement, for example, you can do SBC charting, you can do system analyses as you roll the technology out to try to make sure you're getting the perceived impact. If you're not, then you have to beg the question and take another look as to why are we not seeing benefits, because we can't add cost to our bottom line. Obviously, we're in a competitive market, so we have to get that return on the investment, and we have to measure. Otherwise, we're going to lose confidence from all of our stakeholders involved. Yeah,
understand. You talked about the living lab. I love that term. That's definitely something I'm going to use as I talk to production systems. You know, that's certainly in some ways just a pilot smart barn like Dr. Rosero shared with the Hanor system. Do you think, Caleb, that as you build research barns in the future, that you need to make substantial changes to the design or function of those research barns to be smart farms? Or do you think the living lab is just kind of a continuation of the research barns and then taking that one step further into the field?
Yeah, obviously the living lab is the first choice you would make is a research barn where you have all the inputs, feed, water, because it's just an obvious synergy there that you can track sensor data and all the other data that you're trying to collect back to actual performance. But in my opinion, the living lab can't just operate within a research barn. It has to be in a commercial field setting, because typically your research barns are not in all the geographies you operate within and don't have all the flows of pigs that you have in your system. So I think you have to have field sites, test sites, living labs across your system to really understand how the technology performs across the range of scenarios that you have within your system.
Yeah, very good. Well, thank you very much for the information, Caleb. It's great to see you as always, my friend. Please share my best with everybody back there at Mash-Offs. I'd start to list people to say hello and hi to, but I would waste the next 20 minutes. So good to see you, man. Tell everybody there I said hi.
It's great to see you, and you're looking good.
Thanks, buddy. You too.